Thanks, 203. Today's topic is going to be modular exponentiation. We have this problem set up where we want to compute 7 to the 14 mod 47, but we'd really like to avoid doing that actual computation. 7 to the 14 is a huge number, and so that's going to be really tough to calculate. So instead, we're going to use some exponent tricks. The first one I'm going to use is, instead of getting 7 to the 14, I can break that down into two smaller parts by turning that into 7 to the 7th squared. And that's just using our exponent multiplication rule. Now all I have to calculate is 7 to the 7, and that's smaller, but still not something I can do in my head. So I'd like to break that down even a little bit more. I can't divide that one in half since it's an odd number. So instead, what I'm going to do is I'm going to pull a 7 out in front. And so I'm going to get 7 times 7 to the 6th, which is the same as 7 to the 7th using our exponent addition rule. From there, I'm going to do that same exact trend. So when I see 7 to the 6th, I'm going to break that down into 7 cubed squared. And when I see an odd number like 7 cubed, then I'm going to break that down into 7 times 7 squared. And so now I'm left at this point where all I need to calculate is 7 squared, which is something I can do. I know that that's just 49. And to make things even easier for myself, since it's mod 47, I can also subtract 47 to get 2, and those are both equivalent under mod 47. So 2 much easier to work with. And so now I can start working my way back up to get to 7 to the 14. So 7 cubed is 7 times 7 squared. And so I'm going to substitute in that 2 for 7 squared, which gives me 14 under mod 47. For 7 to the 6th, I can substitute 14 in for 7 cubed. So that's going to give me 14 squared. Now, this one's a little bit messier because that's going to be still a bigger number than I'd like to work with. And so to manipulate this and make this a little bit easier, I'm going to say that's 2 times 2 times 7 squared, just using my normal math. And then I'm going to substitute in a 2 for 7 squared. So I'm going to get 2 times 2 times 2, or just 8 under mod 47. You could also just take 14 squared. That's going to come out to 196. And then you could subtract 47 a few times, and that would also get you to 8. Now for 7 to the 7th, it's 7 times 7 to the 6th. And so I can substitute in that 8 for 7 to the 6th, which becomes 56. And then I'll subtract a 47 to bring that down to 9. So under mod 47, 7 to the 7th is equal to 9. And then finally, we're almost there. Last step, 7 to the 14th. I'm going to substitute in 9 for 7 to the 7th. And so I have 9 squared, which is equal to 81. And I'll go ahead and, just like I've done before, subtract 47 from that. And that's going to leave me with 34 under mod 47. So we can see how that took a few steps, but all of the math we actually did was a lot easier than if we tried to figure out 7 to the 14 directly. And so this is a trick that you can use whenever you've got to do modular exponents.